Today we're going to be working on fundamental counting principle. We have a problem here that says, you're in charge of city transportation in Upper Arlington. How many different distinguishable ways can someone travel from point P to point Q if he or she must always make progress towards point Q? So the first way would be here, from P to A, then from A to B, and then from either B to Q this way, or B to Q this way. So that's 1, 1, and 2. Our second way is from P to C, and C to D there's 2 ways, and then from D to E, from C to D there's 3 ways, from D to E there is 2 ways, and then from E to Q there is 1 way. And so we have 1, 3, 2, 1. And finally, we have P to F, and there's 2 ways, 2. And F to Q is 1 way. So we're going to write that over here. We got the P to A path. Whoops, that's an R. P to A path is 1 way times 1 way times 2 ways right here. And that equals 2. So that means there's 2 different ways to get from P to Q if you travel in the A direction originally. Now we have or, because or means plus. We have or PC way right here. And our first is just one option. Then we have 3 different options. Then 2 different options. And then back to 1 option. And that equals 6. So we're adding these. And then we have one last way, which is starting with P to F. So we got or again, because that or equals addition. And the P to F way starts with 2 ways. And then there is 1 way. And that equals 2. We're adding that as well. So in total, we have 10 different ways we can get from point P to point Q. Let's look at the second problem. It says 126,000 has a prime factorization of 2 to the 4th times 3 to the 2nd times 5 to the 3rd times 7. Use the fundamental counting principle to determine how many positive divisors the number 126,000 has. So what this is telling us is that 126,000 can be broken up into, let's say, 2 and 5,000, or 53,000. And this will be broken up, and it'll just keep continuing until we have these numbers as the ends of the branches. So what we look at here is we say, how many 2's are there? So we look right here and we say, well, there's obviously 4 2's, right? But then, excuse me, we look at how many different, so we can have this number, 2 to the 4th, it is equal to, can be broken up into 2 times, so 2 to the 4th equals 2 times 2 times 2 times 2. So you can either have just 2, you can have 4, you can have 8, or you can have 16, or you can have no 2's, so just 0. And so that is 5. So that means we say 5 different 2 options. And we do the same thing for the 3's. And we say, well, we can have 3 squared, which is 3 times 3. So you can either have 0 3's, 3 3's, or you can have 0 3's, you can have 3, or you can have 9. So it's 3 options, so 3. I assume you are seeing the pattern here. That leaves 4 5's and 2 7 options. So this isn't the amount you have, this is just the options. And if you multiply all those out, that equals 120 different divisors. That's a D. Divisors that any one person can have. And these are just the positive divisors, but how many positive divisors any one person can have for the number 126,000. I hope this helped you guys.